All right, so in the last part of this lesson, we're just going to go through a basic example using this theorem that says that if we take the derivative of the natural log of the absolute value of some function, then that's simply equal to, in this case, that function's derivative over u. So if we're taking the derivative of the natural log of the absolute value of u using chain rule, that would just be u prime over u. So in other words, we don't have to actually really worry about the absolute value expression, as long as the function is not equal to 0. But let's go through an example to clear this up. So here we're going to find the derivative of f of x that's equal to the natural log of the absolute value of the cosine of x. So all we simply have to do is use the chain rule. So let's first use the logarithmic property. So the inside function is the cosine of x. So we're going to have 1 over the cosine of x multiplied by the derivative of the cosine of x, which will be the negative sine of x. So again, we don't have to worry about making this positive. So we can just leave it as a negative sine of x. So this will be the negative sine of x over the cosine of x. And that just becomes the negative tangent function of x. That's simple. All right, and now in problem 6, we're gonna locate the relative extrema of this equation where we got y is equal to the natural log of x squared plus 2x plus 3. So let's not forget the whole strategy to finding relative max or relative minimum, which we want to essentially find the critical points. So we want to find where the derivative is undefined or equal to 0, and see what the behavior of the function is around that point. So let's first find the derivative of y. So we got dy dx. We do 1 over the inside expression. So we're going to have 1 over x squared plus 2x plus 3 multiplied by the derivative of the inside. And so multiplied by the derivative of x squared plus 2x plus 3, which will just be 2x plus 2, which will be equal to 2x plus 2 over x squared plus 2x plus 3. Okay, so this is our derivative equation. So we have to now make this equal to 0. So we have to make this 2x plus 2 over x squared plus 2x plus 3. We got to make it equal to 0 or find where it's undefined. So we essentially just first have to solve for when is 2x plus 2 equal to 0. And it's simple. We can solve for x and find that taking away 2, dividing by 2, x will be negative 1. So that's going to be one of our critical points. Now, we want to see if there are any undefined values, but we don't have to worry about that because there aren't going to be any undefined values since the derivative, or since the denominator won't be 0 anywhere. So let's go ahead and then make our interval broken up at negative 1. And we want to just pick a value to the left. Let's just say negative 2, and a value to the right. Let's just say 0. And we want to see what's going on with the function to the left and to the right. So let's evaluate what f of negative 2 would be and what f of 0 would be. We only care about the sign, remember that. So f of negative 2, so, or I'm sorry, f prime of negative 2, and f prime of 0. So f prime of negative 2, we would have negative 4 plus 2. So negative 2 over 4 minus 4 plus 3. So we have a negative number. This is less than 0. So we know it's negative here. Now f prime is 0. That would be 0 plus 2. So 2 over 0 plus 0 over 3. That actually doesn't tell us anything. Or I'm sorry, that actually does tell us something. For some reason, this is a positive number. It's 2/3 greater than 0. So what this is telling you is that the function f is decreasing. It's going downward. And on this interval, the function is increasing. So that means there's going to be a relative minimum at -1. The relative minimum at -1, comma, f of -1. And let's just see what that would be. So -1, let's plug -1 in there. So we would have the natural log of -1 squared. So 1 minus 2 plus 3. So 1 minus 2 plus 3, so the natural log of 2. If we want to get very clear, and it would be about 0.69. And so our minimum, relative minimum would be about -1, comma 0.69-ish. And there you go.